Thank you, Richard. And it's an interesting topic, this whole thing of performance-based design, the alternative to Technical Guides Document B. I don't know, will I do it the best version in a 30-minute talk, so I'm going to do a bit of a quick move through a whole load of relevant issues from my point of view anyway, that would come up when you're trying to do a design for a building other than following TGDB. We're now onto our fourth version of Technical Guides Document B, and from the very beginning in 1992 there was always an alternative approach. It was always permissible to come up with a fire safety design, submit for a fire safety certificate, and not use the TGDB route. And that's no different in the current version. What is important to realise about the current version is that it's the whole tone of it is very, very clear, is that you either use TGDB or you set it aside completely. And alternative versions, they're really, historically, I think fire officers have been very, very flexible in that if there was to be a compensating feature in terms of your design, that you could substantially use TGDB and then make a case for varying something within your application without dumping the entirety of TGDB. The tone of the document, I think, is probably starting off slightly differently in that the alternative design codes are put into an appendix and set aside outside of the thrust of the 2024 document. But look, practice can often be different to what the impressions that are given. So when it comes to the applications being made under the 2025 regime, it may actually go back to that approach as well. But we'll see. That'll come from practice. The structure is very, very similar from everybody's point of view. I see there my left-hand side has got very, very big. I don't know if that's a thing on the slides. Hopefully it won't interfere with the content of future slides going on. But and it's been mentioned already this morning about B12 is the only variation. So from our point of view of looking at design and alternative solutions, once you get rid of Technical Guides Document B, you're really looking at either British standards, American standards, or some other jurisdictions' standards. Ireland hasn't published alternative documentation to Technical Guides Document B for compliance with the building regulations. It has it for existing buildings, but not really for them. The three principal ones are British Standard 7974, 9999, and then 9991 for flats. Now, I'm going to take my view kind of has come about to it that I think 9991 is going to be set aside, and really the inclusion of all the flats content in terms of fire safety design within the new TGDB is good enough that it's highly unlikely that people are going to really go to 9991 as your design code for flats. The odd person might do it, but I think the next version of TGDB 2024 is enough to deal with those issues that come up with flats buildings. It's detailed enough, which will really leave us with the choice of going down 7974 or 9999. 7974 can be used for any building, any situation. It's not a prescriptive code. It doesn't tell you how to solve things. It doesn't give you the answers. It just sets up the framework for getting the answers. 9999 is a hybrid document in that it is a prescriptive code, but there's flexibilities built into it. And it's based, to a large degree, from a fire safety point of view, it's based on risk assessment. Now, one of the things to note in relation to, and the slides have really gone awry, is there any way of correcting the... Anyway, not to worry. The published version will look fine. When you do make your application, I think the first thing to get across is that the documentation that's lodged to get a fire safety certificate doesn't tell you how to comply with the law, whether you use TGDB or not. It's very much a choice to use Technical Guides Document B. The building control regulations and the grant of a fire safety certificate is not based on having to use TGDB. Any other acceptable alternative code that can be agreed between the Building Control Authority and the applicant is equally acceptable. And that's an important distinction to make. But the requirement to demonstrate compliance is still there. And one of the important things that comes out of the actual regulation itself is that you have enough information to inform the assessing officer that your Part B design does actually comply with Part B, can be shown to be compliant with Part B. Now, the documentation that fire officers get, or that building control authority gives out, is demonstrate, and technical guidance document B, ironically 2024, says prove compliance if you don't use TGDB. So whether it's demonstrate or prove, the approach is going to be similar. And so TGDB is a prescriptive code. It tells you exactly what to do. You as a designer, all the hard work has been done for you. Now, people using TGDB mightn't think so, but you don't have to decide what the travel distance is. You don't have to decide what type of fire alarm system to use. You don't have to decide what the fire rating on the walls, the floors, the linings are. TGDB has prescribed it for you. When you go to a performance-based design, that's gone. Everything you do must be decided by you, the designer. You must decide what the relevant travel distance is. You must decide what the fire rating on the floors, the walls are, how combustible the wall, the ceiling linings are. All of those simple decisions that TGDB does for you are actually back onto your court and onto your liability. And the assessing fire officer or building control officer has to agree with that as well when they accept that design and make a recommendation in relation to granting a fire safety certificate when it's a performance-based design. And an example of that would be, the general thing would be maintain tenable conditions so that the structure remains stable. Well, TGDB decides for you what that means. You don't have to make anything up. You don't have to go into the science of it. Whereas with a performance-based design, you actually must come up with all the tenability criteria. You must do the calculation of the actual, how long does it actually take for the occupancy to leave this room, to get to the story exit, to go down the staircase, and then all the complications of everybody else in the building using the same escape routes at the same time. You must figure it all out when you do a performance-based design, and then you must present it so that it's convincible to an assessing fire officer. Now, whether it's performance-based or whether it's prescriptive-based, the strategy is still based around very similar things. It's still a B1 to B5 concept, because there's 5 legal building regulations. There's issues to do with fire prevention, to do with the combustibility of materials, your escape routes, the number of people in the room, the number of exits, where they're distributed, how wide they are, what they lead to, how far away they are from your story exit, from your final exits. You must make similar decisions in relation to compartmentation. Are you getting rid of compartmentation? And if you are, what are the appropriate compensating features to it? In a performance-based design, it's all open for you. In a prescriptive-based design like TGDB, TGDB sets out a limit on the floor area of your compartment, on the cubic volume of your compartment. With a performance-based design, there's no such limitation. It's down to what you can convince the assessing officer is acceptable within whatever the fire safety strategy is that you're proposing. A lot of performance-based designs will use fire suppression systems. Now, TGDB relies on sprinkler systems, but there's other systems out there as well, including water mist and gas suppression and other forms of fire suppression. And there are also, typically in performance-based design, there will be a big emphasis on the nature of the facilities for the fire brigade to intervene. And you won't be bound by the same limits that TGDB might set for heights or depth or distances. So with prescriptive codes, there are limitations to them, and an awful lot of situations in the built environment that you want to design for are too restricted by the likes of TGDB. So things like the volumes of compartments are a typical example. So a 4,000 square meter shop, if it's to be bigger than that, TGDB doesn't allow it unless you put in a sprinkler system. But there may be other grounds to be able to say, well, what if we were to raise the ceilings? What if we were to increase the number of fire exits? Why can't I have a 4,500 square meter compartment? It's not that different from a TGDB compliant solution without paying for a sprinkler system. Well, in those circumstances, you really are going to move over to the likes of British Standard 9999. It's a very similar prescriptive approach, but there's abilities within it to expand the size of compartments, the lengths of travel distances, subject to you doing other provisions. Or ultimately, you might go down to British Standard 7974, where you start from scratch on everything, and you can show that your fire safety strategy delivers as good and as safe a building as you would if you were to do it under TGDB. There's a whole load of other situations like basement car parks, whether sprinklers are in them or not, whether sprinklers are required or not. Recreational environments, there's a whole load of open plan situations that TGDB may not allow for and that you want to propose as an architect or as a designer. So therefore you'll go down a different route, and you'll go down the route of 7974 most likely. And then behind all of that is, don't forget, is that there are assumptions in relation to our fire safety strategies. Like the Grenfell Tower fire, at the time when it occurred, the British strategy was that of stay in place. So everybody who rang the fire brigade were told just to stay in their apartment. The fire brigade will come, will rescue you, and you'll be taken out safely. Well, the strategy in Ireland isn't that. Strategy in Ireland, by and large, is fire alarm activates, you leave the building. Now, that's all up for grabs when you go into a performance-based design strategy. You've got to convince the assessing officer whichever of the strategies, or maybe a hybrid version of them, is acceptable or not acceptable. I've mentioned 7974, and there's 9999. I think the 9991 code is going to be less and less used. It will be used a little bit. There are other ways of doing it in terms of performance, and you can use computational fluid dynamics and computer programs to design your means of escape and to show how compliant it is. There's also American codes. Now, there's the International Building Code, but that's really an American code. It's called international, but it's actually based in Illinois in the United States, and it's really only used in North America. It can be used in Ireland, and it has been used in Ireland, particularly for large American direct investment companies. But one of the things is that it must be a licensed practitioner has to come and assess it. But it's actually an American code, and it's very, very flexible and a very different basis to the likes of Technical Guidance Document B. And then you've got the National Fire Protection Association, the UK, in the US, the NFPA. NFPA 1 is their general fire safety code, but the life safety code, NFPA 101, is also a basis for design and compliance. And every now and then you'll hear of designs being submitted to show compliance with Part B based on those codes. Now, they've got to be modified, obviously, to refer to European tested products and the built environment in Ireland. When I first came across NFPA, the big thing was they go for pillar hydrants in the United States, and we didn't have a standard for pillar hydrants. Well, there actually is now an Irish European standard for pillar fire hydrants, along with the BS 750 standard for hydrants. So things do evolve. Fabulous buildings, like we'll see there, the Gherkin in London, very, very different style of building. The structure is on the outside, this lattice type structure as an example for this one. Multi-story buildings, well over the 30 metres, an awful lot of them over the 60-metre heights. TGDB won't apply. So therefore, there has to be an alternative approach to trying to show compliance with Part B for them. B1 to B12 applies to these buildings as it applies to a 2-storey building anywhere in the country. But you get some very beautiful looking architectural buildings like the Capitol Gate in Abu Dhabi. And there's loads of them, and we're starting to get to see them in Ireland now as well, which is great to see. And when it comes to Part B, all the knowledge that somebody has built up in using Technical Guidance Document B still is relevant, because everything you do in relation to building up the picture of the building is used when it goes to performance-based design. So everything from issues to do with a single staircase, multiple staircases. What are the benefits if you add a second, a third escape staircase? What compensating features does that introduce to change the design? And everything all the way down to setting out what your purpose group is because of the fire loading. In a performance-based design, you've got to identify the fire load for every single room, and where you're leading to is how fast will that fire in a room turn into a flashed over fire? And will it, based on your fire safety strategy, will the flashover be controlled by a sprinkler system or a water mist system or something similar to that? And that's all got to be presented in your design. Same issues to do with working out your occupation figures. It's all space factors on the numbers of people per square metre. All the typical fire safety measures that we take, whether it's detection, emergency lighting, fire-rated screens, fire-rated doors, all of those things still have to be included in a building that is a performance-based design, but there's no rules telling you where exactly you must do it, other than what are the consequences when a fire occurs in each of the cells of the building that you've designed for. The big thing really that sets performance-based designs apart are the degree of smoke control that must be designed and provided for, whether or not, and the probability is yes, that there'll be a fire suppression system by way of a sprinkler system, and then the impact that that has on the degree of compartmentation in terms of the subdivision of your stories, and then within the different stories of a building. And of course, there's a huge benefit from an architectural point of view to go down the road of a performance-based design to avoid issues to do with compartmentation. But I love this diagram. It's taken from one of the British documents, do means of escape, but it's all the same issues that go into means of escape, from occupancy all the way around to emergency lighting and exits. All of those issues still have to be addressed regardless of the approach that you take. So if we first off just look at 7974, and this is a whistle-stop tour of 7974. The latest version is 2019. The objectives are very similar to what you would imagine, is that it's a framework, it's a structured framework. While it doesn't give you the answers, it gives you how to set up to get the answers. It's not that you just make it up yourself. There is an entire structure to it, and it's set up so that your assessment is very objective of the 5 building regulations of B1 to B5. Benefits include the fact that it sets up a very disciplined approach. There's a number of subsystems that you must address in terms of your design. You must keep proving the fact that you're achieving certain outcomes, and you've got to go back and reiterate through your design, and I'll explain where that comes from. But what's great about it is that while it formalizes your approach, it still allows you to be very flexible as a designer. It's not prescribing how you end up, where you end up with your fire safety strategy or your fire safety design to give effect to the fire safety strategy. So what it actually does is that you've got the basic code, and then there's 8 published documents. And these 8 published documents address some very basic issues to do with the initiation, the development of the different fires that could occur in the cells within the building. There's a published document for that. There's the published document for the spread of smoke and toxic gases from the room of origin that might travel through the building. Then there's a document for you've got to answer a whole load of issues that arise up from the document. The answers aren't in it, but you've got to give the answers to the questions and the issues that it poses. So it's very reflective of the skeleton of a technical guidance document approach without telling you what the prescribed answers are. And then it goes through things like the structural response, the fire and activation of the fire protection systems, whether it's sprinkler, whether it's detection, shutters, curtains, all of those type of responses as the effects to the cause of whatever the smoke and the heat of your fire actually is. And then also a section on fire service intervention. And that can be an important one that people get wrong. People really have to understand how the fire brigade arrive at the building, how they set themselves up, the facilities, the resources, the measures that the fire brigade will use, how they will actually get to the different seats of fire, how they'll use the building itself, how the building is, particularly with performance-based buildings, how they're evacuating and how the fire brigade get in while they evacuate. So there has to be a very good understanding of the way the relevant local fire service will respond, whether it's a full-time or it's a retained fire service. And then also, you've got to deal with the evacuation of people. Ironically, I would say that probably, would I say 99% of the buildings that we currently apply for fire safety certificates based on TGDB, very few people ever deal with the evacuation of the people on the building. It's taken for granted that your compliant design with TGDB deals with evacuation. But that actually really isn't true. I think there's a growing recognition that there needs to be some kind of an evacuation plan considered by people as well, particularly by fire safety consultants. And the more complicated buildings become, the higher they become, the way in which people will evacuate is a really important part of the fire safety strategy. And it can't be taken for granted in a performance-based design. So you actually have to deal with it as part of one of the subsystems. And then lastly, there is a published document on the probability, the risk probabilities of the different fires that will occur within the building that you're proposing. And there's a whole flow chart, like honours flow chart, and checking, have you addressed this, have you addressed that? And that's set up in 7974 as well, which is very helpful for the users. So you've got these subsystems, subsystem documents that address those basic issues. And there's a huge reflection, honestly, of the content of what's intended by TGDB anyway. And certainly there's a correlating reflection with building regulations B1 to B5. I would say that the biggest ones that vary from a prescriptive approach is the whole thing of the development of fire within an enclosure. TGDB is based on creating loads of cells within the building. We call them protected enclosures, protected lobbies, protected corridors, enclosed rooms, or compartments. With a performance-based design, you may have no enclosures. You may deal with fire spread in a completely different fashion rather than enclosing the fire itself. Now, it's very hard to get away from not enclosing your high fire risk areas, and that's fair enough. But it's not prescribed what you must do. The other one where there's a big variation is in relation to the structural response, is that because a lot of performance-based solutions will rely on a sprinkler system, there's very good grounds to reduce the expected period of fire resistance of the structures, particularly in relation to secondary elements of the structure of a building, and then also is to either to reduce the extent of expected compartmentation or to do away with it altogether because of the nature of the design. And one of the things to take notice in the new B1 to B5 is that it's a life safety requirement. is the current reference in B5 to protecting property is gone in the next version of B5. So the fire brigade are there to protect life, not to protect property. So that inference, you could say, in the need to have enclosure by way of compartmentation, it's not as obvious in the next version of B1 to B5, if you want to use that argument anyway. So when you get into the actual guts of doing a design under 7974, there's an iterative process that one must go through. So you start off with your architectural design of the building. You'll start off with a basic fire safety strategy, and then you've got to populate that strategy. You've got to populate it with all the fire characteristics of the walls and ceilings, linings, of whatever the degree of enclosure that you're proposing. You've got to show when the fire starts in the various different scenarios, and you've got to choose your scenarios correctly, because those scenarios ultimately have to be presented to the assessing officer, who's got to accept that they reflect what the likely sources of fires or the likely fires that will occur in your premises that will put the fire safety strategy to the test when the fire occurs. So the first step it's got to go through is a review of the qualitative aspects of your design. You then got to go through quantifying all of that as to what happens when the fires occur. And then you've got to assess it against the criteria. Now, what's very important is what the criteria are is the acceptability of tenability limits. So how hot a room is allowed to get, how much smoke is allowed to seep down to obscure pathways, how clear must the air remain, how much smoke are people allowed to breathe in your particular building or not. TGDB has decided all of that for you already. You don't even have to think about it when you use TGDB. But when you go to a performance-based design, you've actually got to set out these criteria. And they set the baseline against which the design of your performance-based building must always remain above those tenability limits. And you've got to keep going back with the outcomes of every single individual fire scenario to prove that the response to the fire scenario doesn't breach those tenability limits. All of that gets packaged into a fire safety report, fire safety drawings, gets submitted in exactly the same way for a fire safety certificate, but now the fire officer is assessing and they've got to agree with whatever your acceptability criteria are as well. So whoever is doing the design, that's really a good consequence of our fire safety certificate application system, is the fact that an independent, uninvolved person has to approve, agree with your design, and if they don't agree with it, they can refuse your application, they can get you to change your application, and then ultimately it's the same thing, going to onboard plan all if there's a completely different opinion and view of it. So in the quantitative analysis, you're looking at the development of the fire, smoke movement beyond the room of origin, response of the structure to the fire, activation of the detection and any fire suppression systems, the extent of fire brigade intervention, the human response to whatever the warning systems are, the evacuation of the occupancy, and then a risk assessment attached to that. In terms of the probabilistic approach, your design, you've got to check your design against things failing. So in the normal course of things under TGDB, you assume all self-closing fire doors are closed. There's no such thing as the door is hooked open, the door remains open. In a performance-based design, you actually have to check the sensitivity so that if a door remains open, what are the consequences and what are the probability of that having a big knock-on effect to the main fire safety strategy? And that it's based on the probability of it occurring, of course, and then probability of failures in fire safety systems and like must be looked at, because nothing is prescribed. So therefore you have got to be able to show that there's going to be a robust management system, a robust maintenance system of your fire safety measures that are giving effect to your fire safety strategy. And do keep in mind the acceptability of failure varies significantly. Not only between everybody who's in the room and listening online, people have all different opinions as to what's an acceptable failure. Like when a fire occurs, is it acceptable that 10 people breathe in smoke or that no one breathes in smoke? Like I've come across it on the continent, fire safety designers, their acceptability of people breathing in smoke during a fire is much, much higher than what most fire safety consultants in Ireland are expected to allow for. And I'm quite surprised the degree to which different jurisdictions will vary as to just how much damage is a fire scenario allowed to do to the occupants, and that's considered a success. Or does everybody leave and no one breathed in any smoke, no one felt the heat of the fire, and everybody evacuated within a very short period of time? So societies can vary as well, and whether that feeds into our probabilities does matter. The only one place where I have been able to come across in relation to the acceptability or the probability of death is in 9999 does actually mention it. I think it's 10 to the minus 5 is if you can show that a fatality cannot occur in at least 1 in 50,000, or is it 500,000, 50,000 occurrences, then that's an acceptable probability. But look, that can differ, but you must submit something to the approving authority, to the building control authority, for them to agree with. So then we do our qualitative design. You determine the characteristics of the people in the building, the objectives of your protection, the fire hazards in the use of the building depending on its occupancy, the potential consequences when a fire occurs and the hazards that arise because the building is now burning compared to what it is in its day-to-day, the evacuation strategy that suits the actual occupants 24/7, 365 days of the year, Christmas Eve, New Year's Day, every single different scenario during the course of the year. You've got to be able to establish that your evacuation strategy for that design and a performance-based design does actually work. TGDB doesn't make any difference between Halloween, summer holidays, Christmas. It makes no difference whatsoever. TGDB is one design for everybody. But in a performance-based design, you've got to prove it. You've got to specify then the different scenarios for an analysis to be shown to reflect that your fire safety strategy actually works. So you go through all your iterations, and you've got to be able to show that your analysis then delivers the tenability limits that you have to set at the very beginning, in the full knowledge that the assessing officer is going to agree with those. You want to make sure that they're going to agree with those tenability limits. Now, various factors that should be taken into account are the probability of any particular type of fire occurring or not. And that's going to be occupancy and risk-based. The severity of a fire. If you don't have a sprinkler system, your fire can go to flashover. If you have a sprinkler system that's tuned into, you can show that a flashover can never be achieved. So you can actually control the temperatures. And the simple rule of thumb for flashover is 600 degrees centigrade. So if you've no sprinkler system to control the growth of a fire, it's going to get very, very hot in every room of origin enclosure wherever a fire occurs. So no one's alive at 600 degrees centigrade. So therefore, when the flashover occurs, and flashover can occur in a very short period of time, everybody needs to be out of that enclosure. So in a performance-based design, you've got to include the degree of severity that will occur in your particular design. And then the whole thing of just the spread of fire and smoke, and statistically it's smoke that gets to everybody eventually. And then also the consequences for people in and around the building, which is no really different for a performance-based design versus a TGDB-based design building. So there's an iterative process that you go through, and you've got to keep going back on your iterations You'll start off with the simplest version of your fire safety strategy. You'll find that it doesn't, probably will find that it doesn't deliver the tenability limits. You've got to tweak your design, you've got to improve it to get it to the point of when you get to an iteration where you can show that for all of your fire safety scenarios that the tenability limits have not been breached, whatever those acceptance criteria are. And within 7974 is a very good matrix for all the different subsystems versus all the different parameters that you need to think of. And all the parameters are typical things, that, the fire safety measures, details to do with the occupants, the combustibility of your linings and walls and ceilings and even on your floors, the content, furniture, the activities, the materials that are stored or brought in, all of those things have to be included, and you've got to answer the 7974 published documents for each one of those issues as they might affect the design on the actual matrix. But again, it doesn't give you the answer. As an example, technical guidance, this is just a very simple image of a protected corridor sitting on a fire-resisting floor, and you've got two walls that rise from the structural floor to the soffit of the structural floor overhead. And typically, technical guidance document B will tell you whether the period of fire resistance of that wall, if there's a plenum space above the wall because there's a suspended ceiling, must there be a cavity barrier in there or not? So TGB has already made the decision to tell you must put it in or you don't have to put it in. In a performance-based design, it doesn't tell you that. You as the designer are now TGDB. You must step in and decide whether that's a fire-resisting ceiling all the way through, whether that is going to have a cavity barrier or you're going to extend the wall all the way up to the underside of the floor. You're going to decide the period of fire resistance of the wall, the period of fire resistance of the floors, indeed whether that's a compartment floor or not a compartment floor. TGDB makes all those decisions for you. You don't even have to decide it. Whereas in a performance-based design, none of those decisions are made for you. You make them and you check it through the iterative process whether it delivers your outcomes or not. So there's an awful lot more in it, and there's an awful lot more liabilities involved. And the basic concept of means of escape is that your available safe escape time, the ASET, must always be more than your required safe escape time. And that's going to be made up everything from the time from ignition to evacuating. And just because an alarm goes off, and for instance, we all assume it's an audible alarm. Well, it could be a flashing light. It could be a vibrating form of warning. It doesn't always have to be an audible alarm. But whatever it is, just because it activates doesn't mean people move. People only move who are trained to move. People who are awake to moving. Like North America, if a fire occurs in a building in the United States, they're trained, they move. They don't sit back and wonder, I wonder, is that a real thing or is that a false alarm? In Ireland, it's probably a false alarm, they're probably doing a test. No, the kitchen could be burning. But we sit there waiting to wonder whether we will or we won't. Cultures differ between different jurisdictions. It's incredible. So you've got to consider the time to evacuation. And the time to evacuation includes everything from the time from ignition to detection to alarm, pre-movement time. Irish people have a long pre-movement time. North Americans move very quickly. We have to wait for the smoke to be burning underneath our feet. Say, oh yeah, there's a fire in the building, I suppose I should go. And then the travel time. And we'll all vary on our travel time from the point where we're occupying to where we are outside at the assembly point, or at least out when we go to the final exit, as we step out into the open air where we expect it to be safe. But we're all in a big room here. When we were in our bedrooms last night, the travel time was an awful lot longer because you've got to wake up, you've got to get out of bed, you've got to respond, you've got to get out into the corridor, you've got to go walk the full length of the corridor, all of that. That takes minutes. everybody else is doing it at the same time as you. If we're in a wheelchair, if we've got a broken leg, you're taking your time, if you're blind, if you're deaf, the response can always be very, very different in times of travel time. If you're with somebody, making sure that they also evacuate safely, your evacuation time can take longer. Where we are in this room, there's a door out to the open air immediately within a short travel distance. So our travel time is very, very short. All of that has got to be designed into your required safe escape time, and all of the scenarios, it's got to be less than the available safe escape time based on the configuration of your building. You can model all of this, of course, then, is that you take the architectural configuration of the building, create a computer model of the building, put it into a software package that figures out how long it's going to take for everybody to evacuate in all the different configurations. There's both the egress modeling. It can be a very simple model based on just simple actions by people and the density of the people within a particular room to evacuate that room. And then that's going to be repeated for room after room after room through a multi-story complicated building. Or you can have a very complex software model that looks at each individual person and as a node, and each person then you must make sure that every single one of those individuals within your model actually evacuates as well in a performance-based design. One of the fundamental things is this thing of time to flashover. And it's important to note that time to flashover is both the basis for our classification of combustible materials in the reaction to fire standards that were mentioned earlier, and also in the Eurocodes. But flashover is really seen as the ultimate consequence of a fire occurring, which will preclude life safety. And if you can prevent and stop that, obviously then you can make sure that you've got a much safer building. Very quick, brief look at 9999. As I said, it's a hybrid code. Again, you end up having a fire safety strategy, but it's really based on a risk assessment. But 9999 is really helpful. If you can't fit your building into TGD B, it's really helpful to go to 9999 because it's very, very similar in terms of structure, but there's a number of aspects to it that allows a more expandable fire safety strategy, and it's fully acceptable. But if you do go into 9999, you're really leaving TGDB behind. Everything to do with B1 to B5 has to be dealt with under 9999. Now, with B5, I think always historically the content of B5 is still applicable by and large, and 9999 it has actually been used by people to detail aspects that TGDB may not historically have had details for. But I think the 2024 version of TGDB has taken the wind out of a lot of those scenarios because it provides details for compliance for specific aspects that 9999 may have been used before. But when it comes to things like compartmentation and open planning, it's not for residential buildings, by the way. You'll probably find anyway that TGDB 2024 is just as useful for open plan apartments and residential buildings anyway. But 9999 is very useful for very large, if we call it warehouse type buildings or heritage buildings or architecturally imaginative designs that you want to move away from the compartmentation requirements. So the first thing with any fire safety strategy under 9999 is that you've got to risk assess all your activities. It's based on risk profiles. So you've got to have a very clear understanding of the activities and the people who are going to be affected by a fire. The anticipated severity of the fire, the potential spread of any fire, the ability of the structure to resist the spread of fire, and then the danger to people in and around the building. Sounds very familiar to TGDB, really, doesn't it? But then you get to risk profiles, no such thing in TGDB, whereas 9999 does, instead of going down the road of just occupancies, it's based on risk as affected by both the activities and by the profile of the people. Are they asleep or not asleep? Is there a large degree of people who need assistance or not within the occupancy? Is there flammable materials? All of those. The factors that affect your design are all the different fire safety measures, and there's a greater emphasis in 9999 on having a very clear fire safety management system, and it sets it into a number of different layers of management system. There's very useful information in 9999 that can be used elsewhere, and one of those parts has been anyway, up until the latest version of TGDB, has when you use an evacuation lift for a firefighting lift. But the fact of the details that go into what constitutes an evacuation lift or not. And although I think now the TGB 2024 has an awful lot more details. Before this, we would have gone to 5588 Part 5. Am I right? Yeah. Anyway, so that's one of the changes that has come up now with the new version. And then just a couple of last words. 9991 for apartment buildings. When it was introduced, it was the replacement to 5588 Part 1. It wasn't accepted universally. If you did use it, if you were lucky enough to apply to a building control authority that would accept it, it had to be the design based entirely on 9991 and not a mix and match. I think going forward, all the provisions that you would have benefited from using 9991 are really carried forward now into the text of TGDB 2024. You're probably going to see less and less need to rely on that as an alternative solution. The fire safety strategies are all very, very similar. Fire doors, flat entrance door, common lobbies, stairs, exterior fire safety. I would actually venture to say is that TGDB 2024 has got provisions which are a little bit more easier to use. The 10 meters goes up to 11 meters. The external escape stairs goes from 6 meters up to 11 meters. So there's a whole load of reasons, and open plan flats, domestic sprinklers. The one thing I keep saying, and somebody might listen at some stage, is it doesn't mention water mist systems. It really does. The next version of it needs to really mention water mist systems. But then all the similar 9991 had all the same similar kind of things to do with the typical fire safety measures you would see, but it did allow for, you got benefits from the introduction of sprinkler systems, which the next version TGDB does include. And then all the same difficulties in relation to external walls and common cavities in external walls and fire brigade access. Just one or two words, because the title of this presentation was to include existing buildings, and I'm gonna take a different view. It's brilliant that the new version of TGDB has a section on existing buildings. I would take the view is that it doesn't actually give you any guidance on the compensating features to adopt. All it says, it's no different to the previous guidance. It just says that you can do it, which is great, but you could do it in any one of the other 3 TGDBs. It doesn't tell you when to trade something off with something else. It still leaves it very much to the practitioner and to the assessing officer to accept it or not to accept it, but it isn't telling us how to do it. It refers obviously to things like you can modify the guidance, but then it doesn't ever tell the assessor where in the guidance you can modify that's acceptable, how much you can modify. Like, for instance, like 9999 will tell you that your basic travel distance, you can increase it by 15% if you do this, this, and this. So like TGDB relies, say take the 18-meter travel distance, dead-end travel distance. That's based on surface linings of a certain reaction to fire, a ceiling height of, in TGDB, it's 2 meters. In the other guidance documents, it's 2.4. But in theory, you can have a 2-meter high ceiling and have an 18-meter travel distance. Well, if you were to raise the ceiling to 15 meters high, what's the compensation that you can get for going from a 2-meter high ceiling, 18 meters in a dead end, to a 15-meter high ceiling? TGB doesn't give it to you. And Section 7 doesn't give the assessor any guidance either as to how to do it. 9999 does. You can increase the travel distance by 15%. You can reduce the effective width by 10 or 15%. But TGDB doesn't. And Section 7 doesn't. So yes, it's great to have a separate section on it, but it's not really giving us any direction, or it doesn't give the assessor nor the practitioner just how much can you modify the design by. And maybe there's going to be a supplementary guidance document to deal with that type of scenario. And that would be brilliant if there was. But it does at least open the door and clarify that you can do it. Now, you're not going to be able to see that particular table. The details of that table is too much on it, but the copy that you get subsequently, you should be able to read through it. But basically all it's doing is that it's taking B1 to B12 and it's looking at the actual legal requirement. What is it actually asking you to do? So give warning of fire. That's what you must do. And then looking at what's the standard of proof that's expected to achieve that, and what are the circumstances under which you would get it. So the appropriate provision that it must be adequate for means of escape. It must be adequate, capable of being safely and effectively used. So if you do a performance-based design, you must make sure that your design in all the scenarios you present to the assessing officer provides adequate means of escape, and it's means of escape that can be capable of being safely and effectively used. Now, you're making that up. TGDB has already made it up for you. When you go down the alternative approaches, you're making that up. And you've got to present enough of a design that convinces the assessing officer that that is complied with. And obviously then the circumstances are that it's in case of fire. So you're only designing in the case of a fire. And I think, yes. Now, we're going over, somebody else speaking now? Or? Yeah. So questions, we'll wait till the general Q&A session, but as was said earlier, I would suggest people just note down any questions they may or may not have, and then that they can be answered in the general session. But thank you very much.
I think what Michael was trying to say there is avoid this stuff and use the technical guidance document where possible, but was too shy to say that. But yes, no, it is really for